got, whatever security you've got on the machines, right? Physical access, security access, Unix access, whatever. So that's pretty much it. So I don't know of anything that's, a layer on top of it. In fact, no, in addition to the lower level security. Right? Anybody else? I don't think so. I don't believe so.
I think of 1.0 they added authentication between the worker nodes.
Yeah, is that? I haven't tried that. I haven't tried that. Yeah, I mean, because in our case, we have all our things run on a VPC, or we have other security mechanisms, so we don't really worry about it. We don't worry about that level of security.
Have you worked with Spark SQL?
Yeah, that's cool.
Comment on its performance and stability.
Yeah. I mean, that thing is really cool. Well, it's somewhat limited. Spark SQL, right? So there's an interesting thing. I'll just briefly touch on that. That's one of the coolest things that they come up with. There's some really smart guys working on that stuff. So Spark SQL, it came out because they have Shark, right? Shark is Hive on Spark, basically, right? So literally, you takes the Hive front end, changes the underneath layers that would have started MapReduce jobs and runs run Spark jobs. And it is faster. We've done, a number of performance benchmarks comparing Hive and Spark, and Spark definitely is better. It performs better. Of course, your mileage varies and so on. So they could have continued going that route, and I think they still are. But I think the thing was that Hive has tremendous amount of dependencies to it, and it's really complex. So they wanted to add this ability to execute SQL within, within your code, so you didn't have to go to an outside thing like Spark and then so on. So that Spark SQL really literally will take your SQL string, parse it, turn it into a sequence of RDDs and create an internal in-memory, and you can go back and forth. It's terribly cool. It's really interesting. The limitation with it is that it does not have, it's nowhere near as mature. I mean, because you got to build a whole SQL parser, you got to build a SQL engine, the planning, compiling, and all of that, and they've done a tremendous amount of work in terms of building the infrastructure to optimize. Mike, his time's out. Oh, where's the hooks coming out? All right. Okay. So it does basic things. It'll do some group bys. It'll do some aggregate functions. There are no window functions, at least not in 1.0. I have not tried 1.1 how many functions they have. So it's limited to your basic select, some basic group by, join. I haven't tried much joins, but it has limitations.
The way at least I did was I did convert it to Avro with Parquet format, and then I ran Spark SQL on the Avro thing, and it works fine. It works really fast.
Yeah.
At the end of the day, it will convert it to RDD, but that's how I did create an RDD, and then I put that into an Avro with Parquet format, and then I ran Spark SQL on that, and it was fast.
Yeah, it's fast. It's pretty cool. And the neat thing about it is, because that's something we do at FINRA a lot, is that there's a lot of problems that are relational, and we do a lot of stuff with Hive, but there's stuff you just can't do with that, and you need to do some kind of a Turing complete code. So we do some of these things where we'll run some Hive process and then run a MapReduce job behind it, and it has to write to HDFS and then read it in MapReduce and then read it again as a Hive view, and so there's a lot of back and forth. But what I'm hoping is that we can do more of that in Spark SQL, so that it'll just be all in one. We can go in and out of different representations.
It uses Hive?
What's that?
It uses Hive too?
You can. You can. Shark. Yeah, you can.
Oh,
if you use Shark, yeah.
Have you found it stable as well?
Yeah, it is. It is stable, and in fact, it's more stable than Hive or Shark, right? Because they started from the beginning, right? Hive, you guys ever used Hive? Again, it's 0.13, right? And it's got a lot of issues. I mean, Terry will tell you, we deal with them all the time. All kinds of Hive issues. Right? Yeah, comment.
Is there an ETL component to Spark? Like we transform the data, like we do in RDBMS, cleaning the data?
Like you mean what specific ETL?
Or maybe a component to it, like if we have raw data, we are transforming it.
Not specifically ETL specific, but it's Turing complete, right? So you could write any code you like to do pretty much anything you want to do. So if you want to,
I think you verticalize the database so that you can compress in memory as much as possible. I don't know whether you are indicating to that. That's a problem. You see, if you're doing in memory, there is no matter you have to compress the data as much as possible. So I'm not sure that.
well, not necessarily. I mean, if you're streaming it, you don't have to keep it all in memory.
Well, that's what the possibility was, that you have to then have to be your memory. But
No, you don't have to. I mean, again, it'll sort of fall back to disk if you know, it'll use as much memory as it can, and after that, it'll sort of.
that is exactly what I'm saying. In streaming, you cannot do that. In streaming, if you do that, then
Right, your performance is limited.
performance is limited.
Right, yes.
Question is that that's fine, that I understand. But for the offline,
Yeah.
you ever get a chance of, I mean, artificial compression, and then you use the kind of graphical database, and you can compress a lot.
Yeah. Yeah, I mean, you're right. If you have, so the less memory you have, it'll limit the data throughput you can get through it. That's really what it comes down to. You're correct. Correct. Right. I mean, the ultimate thing, I mean, you know, if you want that product that I was telling you about before, it used, it was all hardware. It was a pure pipeline. And as fast as the data would come out, 4.5 gigabytes a second, it could process it in real time. But the downside of that is you had to write VHDL to get that, and it's work. All right, so there are trade-offs. Okay, right.
Yeah, you mentioned that you basically have a pipeline at Finwell where you go to Hive and then map position and back to Hive.
Yeah.
Are you guys rewriting a lot of that stuff using Spark?
That's the plan. That's one of the, you know, we haven't gotten to that point right now because right now we're in this big cloud migration thing. So we sort of, there's a huge push to take everything we have in-house that's run on proprietary, you know, exotic hardware and exotic systems and move it all to the cloud. So that's sort of taking precedence right now. But part of that reason, one of the main reasons that I'm looking at Spark and I'm pushing it is because now they're looking at the money, right? Because there's a lot of questions like, well, how much is it really going to cost? And you know, cloud time is money, right? So we run the cluster for a longer time. It's gonna cost. It's different from having an in-house cluster where you don't have to pay. So that's definitely a big part of it. Is if we can reduce the amount of time, and we've done that in a number of cases, but right now it's sort of fall back and just get some stuff out the door. So I think that's coming. Yeah.
I guess it's just to reiterate the question from earlier.
This is just to reiterate the question from earlier. I tend to think of certain tools as query tools and other
Yeah.
tools as transform tools.
Yeah.
I would think of Hive and Pig as something that will give me big data output.
Yeah.
And I would think of Spark or Impala or BlinkDB, something else that would be queryable. Is that generalization fair? And is the primary use case for Spark going to be aggregation queries, or is it also appropriate tool for the T in an ETL?
Oh, it's definitely appropriate for the T and ETL. Definitely. Yeah, and absolutely. Because think about it this way. Could you do ETL with MapReduce? Of course, right? So, and I would argue that Spark is a proper superset of MapReduce, right? Because it has effectively map and reduce functions. So by induction, we can say that it can perform ETL, right? In memory, or at least faster, or whatever. But it's really an extension of what MapReduce does. MapReduce does two functions. They just added many more functions, many more capabilities to it. It's, and like that last bullet here, let me make that point, is that you can't assume that it's going to solve all problems perfectly, and don't assume that you're going to be out of a job and all this stuff like that. It's not the case, right? It's one of many possible parallel processing methods, right? That's probably one of the better ones that's out today. There's other, bulk serial processing, if you've heard of that. Bulk synchronous, I can't forget what's bulk synchronous processing, right? BSP, right? HAMA. There's a bunch of these different things that they work on different use cases. Somebody like, if you're an MPP, if anybody's into fluid dynamics, and that kind of thing, Spark is probably not going to solve that very well, right? The nature of that problem is very different, right? So I would say it works well for a large class of problems. So my big thing is try it out. You know, I mean, it's not hard to try. The price is right, right? Okay.
I think previously you mentioned the only security is that which comes with Hadoop and HDFS sort of out of the box as well.
Yeah, I have not tried anything beyond. If there is, I haven't seen
So
it.
that means like there's no access control to the RDDs. You can read an RDD and
Yeah.
anybody else can see what you read in. And
That process, right? Anybody in that process could read
is
it.
that going to be a problem with FINRA in your particular case? Do you need to have access control over certain transactions and things like that?
No, they do all physical security. We have, separate domains, separate, boxes, separate clusters completely, and they do it at the hardware level, basically. So we don't, no. It's, I guess in theory, and they don't really worry about multiple, like, in one cluster you have many people doing the same job. They don't really worry about that. But also the real plan is we just fire up multiple clusters, literally. Different projects, they just fire up another cluster. That's another beautiful thing about cloud. You need that's another way to get security, because two clusters are not going to talk. It's not, right? So that's one way to deal with it. Okay, wrap up. All right, that's it. The risk is low, so it's faster, right? Not super fast, it's faster because it uses memory and disk more efficiently. Remember, time is money in the cloud and all that. It's open source, which is great. Big note, approachable source code, right? So you can look at it. You don't need to wear your special goggles and go crazy and all that. And there's lots of contributors and whatever, and there's support by many vendors and all of that. And go out there and have fun and have a great day. Thanks very much.
We have some quick announcements.
Oh, by the way, that's me. If you want to, I don't have business cards. Just go.
It's on tape. Some people have asked me where we're going to post the video for tonight, and I'll make sure that a message goes out to Meetup with a link to where the video is, okay? Okay, that was Madhu. Let me run this. Where's Matt Kennedy? Come up here just a little bit. This is our next speaker. I'm excited to give our meetup group early information, because I'll tell you, this meetup completely sold out. We had to turn people away from the door, and we were really sad about that. The next meetup is a trifecta event, because we are hosting it with a DC meetup and the Big Data DC meetup. So I'm letting you guys know ahead of time, because as soon as I post it on Meetup, make sure you RSVP so you get your spot. It's on September 25th. Matt is our speaker, and Add This is going to be hosting us. So it's going to be a pretty exciting